Today is April 26th, and whether you are rewatching this and you were in class or you are absent and you are just following along, please take notes. So there's three things we're going to add to today. We've already learned about three primary trig functions, sine, cosine, and tangent. And I shared with you weeks ago that one way to remember this is using the acronym Oscar had, please write this down, a heap of apples. Oscar had a heap of apples. Remember that when we do sine, cosine, and tangent, those trig functions, all that is please don't work ahead. All that is we're looking at a right triangle. We're taking two of the three sides of a right triangle, specific to what it asks for. For instance, sine asks for opposite over hypotenuse in that order. So we're taking two of the three sides of the right triangle, and then we're creating a ratio that describes it. This is like directions. What are the directions? This is directions. This is directions, and so on. So what I need us to do right now is we need to put this back into a triangle. So let's start by choosing one of these two angles. It doesn't matter which one we choose. Like, I'm going to choose that one. It just can't be the right angle. Now, I know that sine means opposite over hypotenuse. So from this angle, I'm going to go directly opposite to this side, and I'm going to write down 3. It has a length of 3. And then I'm going to go to the hypotenuse of this triangle and put 5. Now, it is possible that the length isn't 3 or 5, but again, it's going to be a ratio of that. Now, the next thing was we're going to use the Pythagorean theorem to figure out the missing side. So remember that A's and B's are legs, and the order you put them in, so 3 could go in for A or B, we get the same right answer. We need to show our work. So 3 squared plus B squared equals C squared. To isolate the B, I'm going to take 5 squared and subtract the 3 squared. Now I know 5 squared is 25, 3 squared is 9. Now if you were just simply solving this, it had nothing to do with this triangle, you'd have two answers. You'd have a plus 4 and a minus 4. Why? Because when you take care of the square root of 16, you get 4, but the square means there's both a plus and a minus. Why are we never considering the minus as we apply it to a triangle? Because we're using Pythagorean theorem to find the missing length, and lengths are always positive. So it's actually considered an extraneous solution, the negative 4 in this case. Okay, up here, please put a 4. So we're going to stick with the three primary trig functions, and this part should be review. So from this angle, opposite is 3, hypotenuse is 5, and I'm done with sine. Let's move on to cosine. Cosine is adjacent. Adjacent means it's one of the two sides that helps make the angle, but it can never be the longest side of the hypotenuse. So adjacent here is 4 in comparison to this angle. So 4 over the hypotenuse 5. Tangent is opposite over adjacent. Opposite over adjacent. All of that is wonderful. Now we have three new trig functions that are called secondary trig functions. Those secondary trig functions directly relate to the three primary trig functions. These two relate, and relate. And all they do is it's command to say, hey, we're going to do sine, but then we're going to flip it. We're going to take the reciprocal. So next to this on your paper, please do the following. H over O, H over A over O. It's like a command to just simply do the reciprocal. So I want to take the sine, and then I want to take the reciprocal. So instead of saying 3 over 5, I say 5 over 3. Well, what is that command? It is the trig function that's called cosecant. Cosecant is always the reciprocal of sine, every single time. All right, so cosine also has a reciprocal. It's called secant, not sec. Secant. This is just an abbreviation for secant. So instead of 4 over 5, it's 5 over 4. And likewise, not cot, cotangent is the reciprocal of tangent. So if you have these three, all you're doing is flipping and you're done. It's as simple as that. Can I have right now a 1 through 5 on how well you understood this particular problem? 1 through 5. Example number 2 is very similar, but instead of starting with sine, we're starting with cosine. Well, let's do this first. Oscar had a heap of apples. Good. Okay. Now I'm going to come up here, and I remember that cosine is A over H. So I take my triangle, and I am going to identify one of the two angles that's not a right triangle. Excuse me, let me go back here. I'm going to identify one of the two angles in a right triangle that's not 90 degrees. So I could put this angle here, or I could put this theta symbol up here. It makes no difference, okay? And then I'm going to go, okay, I know that the cosine of this angle is 8 over 11. That means adjacent to this angle is length 8, and hypotenuse is 11. And now I'm going to use the Pythagorean theorem to figure out this third. So a squared plus b squared equals c squared. I'm going to have 8 squared plus b squared equals 11 squared. So 11 squared minus 8 squared, what is that? All right, that's 121 minus 64. Now 121 minus 64 is 54, take away 11, 57. And it's only a positive because it's a length, and I take the square root. So this is the square root of 57. But before I do anything, I've done this problem in the previous class. We first need to see, can we simplify things? If you're like, I don't know what she's talking about, let me show you one that I know is simplified. So it has nothing to do with this exact problem, but I want to give you an example. If I said the square root of 32, please look up here. Okay, I know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and that's beyond this number. So I want to think of the first perfect square that's below 32. That's 25. So watch. I'm going to go through here, and I'm going to demonstrate how we're going to see, can we break this down? So I take this and I divide it by 5 squared. If I get a nice whole number, I know I can reduce it. Nope. Okay. Then I'm going to divide it by 4 squared. 4 squared. Oh, I wrote that down wrong. Divided by 4 squared. Oh, there it worked. It worked. So what does that mean? Well, 4 squared is 16. That means this breaks into 16 times 2. The square root of 16 is 4. So I just broke down the square root of 16 to 4 times the square root of 2. That's leading into this problem. If we're going to do this right, we have to see, can I break this down? Turn to the person next to you. What is the largest perfect square that does not go past 57? Go. You have 10 seconds. What's the largest perfect square that does not go past 57? So in my mind, I'm like, okay, I missed it. 5 squared is 25, 6 squared is 36, 7 squared is 49, I'm still okay. 8 squared is 64, oh, too far. So 7 squared, 49. So now I'm doing this, and I'm doing it fast. I'm like, divided by 7 squared, oh, that doesn't work. Divided by 6 squared, 36, oh, that doesn't work. Divided by 5 squared, oh, I know it's 25. Divided by 4 squared, nope. Divided by 3 squared, that doesn't work. Divided by 2 squared. None of them work, and I don't have to do 1 squared because dividing by 1 doesn't break anything apart. None of these provided an outcome that was a whole number. That means this can't be broken down, and that's why I was able to write it just as the square root of 57. Let's get started. Okay, sine. From this angle, opposite is the square root of 57, and hypotenuse is 11. What I recognize in the past is students are like, whoa, we got a square root. I don't think this is in proper form. Yes, it is, because the square root of 57 has, we've already attempted to break it down. We can't. And we can have square roots that are in our final answer. They just have to be in simplest form, and they could never be in the denominator. This is good to go. Let's go to the cosine. We already know the cosine is 8 over 11. Tangent is opposite over adjacent. We're good. Now we're going to do the reciprocals of each one of these. The reciprocal of sine is pronounced cosecant. So mathematically, nothing is wrong with this. Well, what's wrong then? What's wrong is we can't leave a final answer with a square root on the bottom. So how do we fix that? We're going to take whatever we need to remove from the bottom, and we want to keep the same value of the fraction. So I multiply the top and bottom, in this case, by the square root of 57. And I'm left with 11 square roots of 57 divided by 57. This is what I have. Now, I need to check to see if this can be reduced. I see 3 values. I see 11, I see a square root of 57, and it's all divided by 57. If you had to think like terms, there's 3 terms here. Which 2 are like terms? Turn to your elbow partner. Which 2 of those are like terms? The 11 and the 57. And so let's see if we can reduce these. Do me a favor. Go to your calculator and hit the green button, and hit the button directly to the right of it. And we're going to take 11 over 57. When we press enter, if it is reducible, it's going to land over here, and it's going to be reduced. It is not reducible. I got the exact same fraction. This is my final answer. Let's do secant, not sec. Secant, it is the reciprocal of cosine. So I take the reciprocal, I'm done. Let's do the same with tangent. I'm going to press pause. working with your elbow partner, you have 45 seconds to find what is the cotangent of this angle and in reduced form. Alright, so here we go. I'm flipping it. 8 over the square root of 57. Mathematically not wrong, but it's not in proper form. So I'm going to take both the bottom and the top times the square root of 57. I'm left with 8 square roots of 57 divided by 57, but I don't know if that's in reduced form. So I'm going to take my calculator, alpha, and then directly to the right, I'm doing 8 divided by 57, enter. Oh, I get the exact same fraction. That means this is in reduced form. Okay, so now I start off with the secant. Instead of me starting off with example 1 and 2, that I was providing you with primary trig functions, sine and cosine, now we use secant. Now we have to recognize that secant is the reciprocal of cosine. So let's start by doing this. 2 square roots of 5 over 4. That's what I'm giving. And then I'm going to do the usual. Oscar had a heap of apples. Okay, you ready? So guess what? If cosine is a ratio of adjacent over hypotenuse, that means that secant is a ratio of hypotenuse over adjacent. Can I have you raise your hand if you agree with that statement? Don't raise your hand if you're confused or you disagree. Hands up high if you agree with that. Okay, so what I'm going to do right now is I'm going to go, okay, I made my triangle. I chose one of these two to have this symbol, theta. It doesn't matter which one. We're still going to get the right answer. And now, okay, this means that the hypotenuse needs to be 2 square roots of 5. Gotcha. 2 square roots of 5. And it means adjacent has to be length 4. So adjacent to this angle is 4. And just like examples 1 and 2, we are now going to use the Pythagorean theorem to solve for the missing piece. And we're going to do this together. We're going to slow this down. A squared plus B squared equals C squared. So A, 4 squared plus B squared equals 2 square roots of 5 squared. Now remember, that means write this thing twice. 2 square roots of 5 times 2 square roots of 5. That's the concept of it. That's the concept. Now why did I do that? Because I think it's easier for students to then see. 2 times 2 is 4. Square root of 5 times the square root of 5 is the square root of 25. But what is the square root of 25? Square root of 25 is simply 5. 5 times 4 is 20. Okay, solve right now for B. You have 10 seconds. Solve for B. Very sloppy. I have B is equal to 2. I have B is equal to 2 after I do the math. B is equal to 2. So what am I going to do next? I'm coming back up here to the top, and I'm going to find out what are the 5 remaining ratios. Okay, sine. Sine is opposite over hypotenuse. So 2 over 2 square roots of 5. Is that mathematically wrong? Absolutely not. But this is a great one for us to talk about. What happens to the 2 on top and the 2 on the bottom? Do they disappear? No, they don't. What do they simplify to? When I tell you this over and over again, remember, they don't just cancel out. What do they simplify to? They simplify to 1s. So 1 over 1. So now, this is, if I could give myself a little more space, this is 1 over 1 square roots of 5. Mathematically, that's not wrong. But what do I do with this to put it in proper form? I do square root of 5 and square root of 5. So I have 1 square root of 5 on top. Well, that's the same as square root of 5. On the bottom, 5 times 5 is 25. And the square root of 25 is 5. 5 times 1 is 5. So sine is going to be square root of 5 over 5. Now I know the cosine is the reciprocal of secant. They're reciprocals of one another. That's the relationship they have. So I'm going to flip it right now. And of the 3 different values in that ratio, the 4 and the 2 are like terms. So I can reduce the 4 and the 2 to be 2 over square root of 5. Is it wrong? Nope, I can do more. What's wrong about this? Mathematically not wrong, but it can't be my final answer. It's not proper. So I'm going to go square root of 5, square root of 5. I have 2 square roots of 5 on top, and I know the square root of 5 times the square root of 5 is simply 5. That's my final answer for cosine. Let's move on to the tangent. Tangent is opposite over adjacent. So from this angle, opposite is 2, adjacent is 4, and I know 2 over 4 reduces to 1/2. So right now I have 4 of the 6. 4 of the 6. Now watch this. I want to teach you how you can be lazy. Are you ready? So here's the long way that I'm not going to do. Here's the long way. I know these two are reciprocal, so I could flip this around, but what would happen to the bottom, guys? What would you have? You'd have 5 over the... Okay, I'm going to do it for those that need to see. Do you agree that these two are reciprocals of one another right now? Yes or no? Yeah. Okay, and then we'd have to go square root of 5 times square root of 5, right? Don't do it that way. Don't do it that way. There's nothing wrong with that. That's a little extra work. Let's go back to what we had before we reduced. Before we reduced, we know this is equivalent to this, but before we reduce, let's flip that. So we had 2 square root of 5 over 2, right? Do you guys agree? If I take this, now what happens to the 2's? They reduce down to 1. That's my final answer done. Let's go over here. If I flip this, I get 2 over 1, which is just 2, and I'm done.